Welcome to Learn to Build and Build to Learn AWS IoT series. In the last video, we talked about different reset related functions. In this video, we'll discuss about different power related functions such as frequency, idle, light sleep, deep sleep. I will also explain the use cases for these functions. These functions may sound very similar, but there are subtle differences between them. Let's dive in. So frequency function returns CPU frequency in hertz. So machine dot frequency. This will give the current frequency, which is 160 megahertz. And as we know, power consumption depends on that operating frequency of your CPU. In case if you do not need that kind of CPU power for your application, you can set the lower frequency and save some power. We can set frequency using the save function, but we need to pass that frequency as parameter. So machine dot frequency. Let's say if I want to set it to 40 megahertz. So error says frequency must be 20 megahertz, 40, 80 or 160 megahertz, but I provided 40 kilohertz. So let me correct it. 3 more zeros and now validate. Now the operating frequency of this module is 40 megahertz instead of 160 megahertz. Setting lower frequency will save some power consumption, and if this module is running with battery, then it will extend the battery life. Another way to reduce power consumption is idle function. You know, clock signal is essential for processing of CPU instructions, and idle function gets the clock signal to CPU and CPU goes into low power idle state. But CPU remains active and can resume execution immediately if any interrupt occurs. And this is suitable for use cases where you need both power savings and quick wake up. For example, if you have a tight loop to check input from external sensors, you can use it without impacting overall performance. But if you need to reduce power consumptions further, then you should consider light sleep and deep sleep. Both function takes time in millisecond as input, and during that time CPU stops executions. Light sleep has full RAM and state retention, so once it wakes up it can resume the execution from where it left. But for deep sleep, it does not retain the RAM and other peripheral state, so it takes time to wake up, and it's more like resetting the module. And you can use reset cause function to distinguish a deep sleep wake up from other resets. You should use deep sleep for long idle periods and maximum power saving. For light sleep, you will get moderate power saving but quick wake up time. So if you think from real world use cases, if you have IoT device that takes soil moisture measurement, then deep sleep is more appropriate because soil moisture is something not going to change drastically in every moment. So maybe 1 or 2 times or few times in 24 hours is sufficient. So in that case, you have enough time to wake up and measure the moisture and report it back to cloud. For use cases like motion sensor based doorbells, where doorbells need to maintain the state and respond quickly to user interactions like pressing bell button or motion detection, in that case light sleep may be more appropriate. And you can see light sleep, deep sleep and idle, all these functions are very close, but there is a subtle difference. So you need to identify the correct function based on your use case so that you can reduce power consumption at maximum level to extend your battery life. Let's go back to Thorny IDE. So I already have code ready here. So we'll try first light sleep. And for both light sleep and deep sleep, we need to pass the time in millisecond. And in case if we do not pass it, the sleep can last indefinitely. So first I set one variable a equals 1. So I will verify after light sleep whether this a is still available or not. Then I am running one loop starting 0 to 9 and printing that counter and taking half second sleep. And when this counter reaches 5, we will invoke this machine.lightsleep for 5 seconds. So we supposed to see 0, 1, 2, 3, 4, 5. Then it will go on light sleep for 5 seconds. Then when it will wakes up, it should continue the execution. So that means it should print 6, 7, 8, 9. Let's run the script. And it is printing 0, 1, 2, 3, 4, 5. Then it went on sleep for 5 seconds. It woke up after sleep. Then it continues the execution. That's why it is printing 6, 7, 8, 9. Let's try to access the variable a. And this is also available. So this confirms light sleep has full RAM and state retention. Now we'll try deep sleep. So we'll change this method to deep sleep. Save. Clear the shell. Run script. Scroll up. And it printed 0, 1, 2, 3, 4, 5. Then before sleep. Then it went into deep sleep for 5 seconds. And after deep sleep, there is no print message. Woke up after sleep. Because it reset that module. And this reset cause is deep sleep reset. It is similar to traditional reset where bootpy will be called. It need to initiate the Wi-Fi connection. Minpy is called. And let's try to access the variable a. And it says name a is not defined. This confirms deep sleep does not retain full RAM and state of peripheral devices. As I was mentioning, reset can happen in many ways. And for any reason, if you need to know the reset cause programmatically, then you can call that reset cause function. So you need to import the machine module, then invoke machine.reset cause. And it has returned 4 help machine. And here we can see deep sleep reset 4. And the same thing is printed when this module restarted at the beginning here. So in this video, we have learned we can use different power related function to reduce power consumption, extend battery life. And these are applicable for different use cases. But if your use case supports, then you can also use different combinations of all these power related function to maximize the power efficiency. That's all for this video. Hope you have learned something from this video. Thanks for watching. See you in the next one.